Hello, my darlings. In this video, we're going to talk about minerals. So previously, we've talked about the Earth's structure and how we have the layers of the Earth, and you learned about a little bit of the characteristics of those layers. So now what we're going to do is we're going to zoom in on those layers, and we're going to start looking at the minerals that are in them. And then we'll move on to looking how those minerals make up the rocks and how the rocks make up the bigger layers of the ground, and then we get those plate tectonics and all that really cool stuff. So let's first focus on minerals, and that's what this PowerPoint is about. So let's talk about, well, what are minerals? That's our next one. So minerals basically have to have 5 characteristics. So in order to be a mineral, you have to have all 5 of these characteristics. So they're all going to be naturally occurring. So they're all going to be found in nature. They're all inorganic, which that means that they were never alive. So organic, if you remember what we talked about a little bit earlier in first semester, organic means that it has organic compounds, that it came from living beings. This one, they were never alive. They are all going to be solid in the natural state. Okay, next one, they all have a definite chemical composition. So if you take every sample of that mineral and you look at its chemical composition, it's going to have the same atoms in the same ratio. So think about how we talked about water. Every sample of water is going to have H2O, 2 hydrogens, 1 oxygen. Same thing here. Every sample of that mineral is going to have the same atoms in those same amounts of each atom. Last one, 5th one. This is that they have a specific crystal structure. So if you could look at their atomic arrangement, how those atoms are arranged, they're going to be arranged in this crystal structure, which is like a repeating pattern. You may have recalled a little bit of that from last year. I think you may have touched base on this one, but basically it just means that they're organized, how those atoms are organized within the mineral itself. Okay, now let's talk about how do we identify them. So there's a series of tests that scientists use to identify minerals, and these are used in the field, and then we were going to use them in the lab, but since we aren't doing the lab, we'll have a virtual lab, but we're still going to use the same tests that scientists would do if they're out working for a university or if they're out in nature actually trying to grab them and say like, hey, this is a cool mineral, which one is it? Same test. We're going to do the same thing. So let's talk about what those tests are. First test, color. So color, we think like, oh, well, we obviously look at the mineral and say like, what color is this mineral? Just by looking at it. Now, the thing is that this is not really an obvious feature because exposure to air and water can change the color of the mineral over time. And so if you think about like a big old chunk of a metallic mineral, if it's exposed to water and it's exposed to air, it starts to look a little bit more tarnished. And that's because you're getting those chemical reactions on the surface. And so that's why you can't use color as the sole indicator. It's one of the least reliable tests that we have. All right, luster. Luster is basically how we are describing the quality of the light that is reflected from the mineral's surface. So if you think of like the term luster, you may have heard the term of lustrous. If you've ever watched a video or a commercial about a hair product, they're like, oh, this shampoo will make your hair lustrous. Well, and they basically mean that it'll make it shiny. So that's what luster is how is that mineral reflecting light? And so we basically put them into 2 categories. You're either metallic or you're non-metallic. And of that non-metallic, you can have this wide range of features. Like you could be described as being glassy or pearly or silky, or it could just be dull. But the main thing is it metallic? Does it look like a metal? And then is it non-metallic? It doesn't look like a metal. Okay. So here's just an example of those 2 different categories of luster. We've got a metallic sample over here. You can clearly see it looks like this is something that a metal would be made out of here. And then over here, you've got non-metallic. And if I was to like even more subcategorize this guy, I would probably say, okay, maybe it's dull, so there's no shininess to it. And I would probably even say that maybe it looks a little bit powdery or maybe oily. So those are just two examples. All right, next test. So the next one is a streak. This is really, really important because this is actually the actual color of the mineral. So this is the color left behind when you put that mineral in its powdered state. So what color is the mineral in its powdered state? So basically what we do is we take a piece of unglazed porcelain streak plate to perform the test. And here's a picture of it. So here's that orange or the unglazed porcelain streak plate right here, and then you literally just take the mineral and you just streak it like a little like that, and then you see, well, what color is the powder that comes off of it. And so sometimes the powder can be very obvious in what you expect, like this dark mineral here gave a dark colored streak, but sometimes you get these little surprises. So you've got this dark black looking mineral, but when you streak it, it comes out this gold streak. But yet this gold colored mineral, when you streak it, that one comes out as a black streak. And so this again is why color, just looking at the minerals by themselves, is not really the most reliable test to do. Streak plate is really, really helpful. Okay, next, hardness. This one is basically how hard is the mineral. So how easily can the mineral be scratched? Now, we use the Mohs hardness scale to give a specific value of hardness to a mineral. And that scale is from 1 to 10. 1 being the softest mineral and 10 being the hardest mineral, like a diamond. And so like super, super hard. And 1 is super, super soft, and where you can just so basically the hardness is determined by how the atoms in the mineral are arranged. But we're not going to get into that into too much detail in this lesson. Okay, so let's talk about this here. We are going to use relative hardness in the lab and in the virtual lab because of the fact that we don't have the capability to assess like all and give it a specific number. So we're going to use relative, which means like how hard is it relative to something else. And the two things we're going to use is our fingernail, scratching with the fingernail, and glass. And so we know that our fingernail, is the average fingernail is typically have a hardness of less than 2.5. And we know that glass has a hardness of 5.5. So basically you take your mineral, and if your fingernail is able to scratch that mineral, that means that your fingernail is harder than the mineral. So then you would say that mineral is going to be less than 2.5 because it's less hard than your fingernail. Your fingernail is 2.5, so it's going to be less than 2.5. Now if you do the same thing with glass, if you take a piece of glass, we know that glass is 5.5. So you take the mineral. If the glass, you scratch it. If the glass is not scratched by the mineral, then you know the glass is harder than the mineral. So we can say that mineral is going to be less than 5.5. If the mineral scratches the glass, then the mineral is harder than the glass. And so the mineral is greater than 5.5. And then if you have a mineral that is, your fingernail cannot scratch it, so that means it's harder than your fingernail, but it does not scratch glass, so it's less than glass. So now we've got it's in that range of 2.5 to 5.5. Make sense? So again, this is relative. It's relative to your fingernail and to the piece of glass. Okay, now let's talk about density. Density is another one. We're not going to do this in the lab, but it is really helpful because some minerals are very, very, very dense and some of them are very, very, very light. And so that can give you an indicator of which mineral it is. So you can use it. I mean, it is very helpful, but we're just not going to use that in the lab. Okay, this one is probably the trickiest one that kids struggle with, and this is cleavage versus fracture. What this test is how does the mineral break? If you just drop that mineral and it breaks apart, is it going to break in a way that it breaks on a flat surface where it looks like it was literally just cleaved in half, like with a knife, like a cleaver, like a butcher cleaver? Or does it break where you got all these rough, jagged edges? And so those are our two categories of breakage. Is does it cleave where it looks like there's one flat surface, at least one, like it just got cut right there, or all those rough, bumpy bumpy edges. And so if it's bumpy, that would be a fracture where you have no straight, clean edges. Cleavage is if you even have one. You only need one clean edge to call it as a cleavage. You can have more than that, but you only have to have one. And again, this feature is also determined by the arrangement of the mineral's atoms. So how they're arranged on that subatomic level. Okay, and this slide here, this little diagram here, shows you how there's 4 different samples here that are actually cleaved in multiple directions. So like this one is cleaved on one flat surface, like a muscovite here. This guy here is cleaved on 2 surfaces, or 2 planes. And this one here is cleaved in 3 planes. And this one here also in 2 planes. And so this just gives you an example of how you can have more than one or just even one cleavage surface. All right, and the last few tests we're going to talk about is taste, smell, and feel. Some minerals will have a very specific taste or a smell to them. Although we will never taste test in the lab safety precautions, but some of your salt minerals are going to taste salty if you would actually taste them. They also have, some of them have distinctive smells, such as sulfur. It has a very rotten egg smells, icky. And then also they have some of them have a distinctive feel to them, to where they feel very slippery or greasy. The last test we'll talk about is the HCl test. Some minerals will react to an acid. There's a chemical reaction. If you add an acid to it, it will actually start to bubble up. And that's shown here. Is we got the mineral, you add a little HCl to it, chemical reaction, reacts to the acid. So that's a really good indicator for some minerals to help you identify those minerals. All right, so how do minerals form? Last thing, we're going to wrapping this up. They either form from 3 different ways. One is they can fall out of solution. Sometimes you have solutions when they start to cool or they're starting to react. You'll actually get this precipitate and the minerals will come out of that solution. Second one is they can come from magma and lava. So we know that magma and lava is just molten rock. Well, when it starts to cool, sometimes those minerals will then start to precipitate out to themselves, and you get this conglomeration of the big old chunk of mineral within a rock that hardens from cooled magma and lava. Third thing is that we have some organic sea creatures, for example, who can actually create their own minerals. So some sea creatures can create their own shell. The shell is clearly just a big old chunk of mineral. And so these sea creatures who are organic will create this inorganic mineral, their shell. And so even though the mineral is inorganic, it's made by an organic species or through an organic process. That's a little confusing. Let that sink in. Okay, last thing, why are minerals important? They're extremely important. Every geological process depends upon the properties of the minerals. Events such as your volcanic eruptions, your mountain building and earthquakes, all of them depend upon how the minerals react, how they work, how they're working together, how they're formed. All of those things depend upon minerals. Third thing is our goods. Jewelry, they're gorgeous. We have tons of jewelry that is made out of minerals. You have big old chunks of them, and you make them nice and shiny, and we can create jewelry out of them. Talc, basically baby powder. We use talc. We also use talc and kaolin in a lot of cosmetics, and a lot of your goods are made from these minerals. So it's really, really important, and we're going to explore that a little bit later when we talk about the specific types. Okay. All right. Well, have a good day. Be good, be kind, be awesome, and recycle.